today we are talking about variation. Okay, so there are a few different kinds of variation. We have direct, inverse, and joint variation. The math here isn't terribly complicated. It's just kind of knowing which one is which, and then being able to use them shouldn't be too big of a deal. Okay, so when we talk about variation, okay, first off, direct variation. So two variables vary directly when their ratio is constant. Okay, so when their ratio is constant, so when it says y varies as x, right, or varies directly as x, you'll see a lot, then what that's saying is that if you divide those two things, you will always get the same answer. Or alternatively, and this is sort of the formula that I use more in my brain, right, that if you multiply your x values by one particular number, then you always get the y value. Okay, so if your k value is positive, then they are either going to increase or decrease at the same rate, right? So as long as this is a positive number here, as x gets bigger, y is going to get bigger too. Okay, so that's sort of what I think about with direct variation. So kind of keeping this guy in mind, right? That's sort of the formula that I keep stuck in my brain. But at any given point, you should also be able to kind of convert this to this format so you could then compare. You're going to have some questions where it asks you things like, is this an example of direct variation? Okay, and one thing that you might want to be able to check is turn something like this into this format. So just working between the two so you can compare them. Okay, and also of note is that it has to be exactly in this format. So if there was like a +5 at the end of this, it would no longer be direct variation. Okay, so that's direct variation. Then we have inverse variation. So two variables vary inversely if their product is constant. So y varies inversely as x means that if you multiply the two of them, you get k, right? Or, and again, this is sort of the equation that I use, right? When you take this number k and you divide it by your x value, that's how you get your y. So just for my brain, like this makes more sense for direct. This makes more sense for inverse, even though they're not technically what the definition of it is. Okay. And then in this guy, again, as long as your k value is positive, as y gets bigger, x gets smaller. Okay. So, or easier to think about is that x gets bigger, your y gets smaller, right? If this is the same number, as you divide it by bigger and bigger and bigger numbers, you're going to get a smaller answer, right? So as one of them gets bigger, the other one gets smaller. Okay, and then the last one, joint variation, is just when you have more than two variables going on. So if we say y varies jointly with x and z, right, it would mean that when you divide y by both x and z, you get a constant number, or y is equal to k times xz. So y varies jointly with x and z. Okay, so let's take a look at how we are going to be dealing with some of these problems. So the work in joules done when lifting an object varies jointly. Okay, so you're paying attention for these key words, varies jointly with the mass of the object and the height that the object is listed. Okay, and then they give us some direct information about some examples of how it's happening. So I'm going to start by writing an equation where it tells you that the work done varies jointly. So varies jointly, that tells me I'm going to be making this equal k and then times whatever my other variables are. So varies jointly with the mass and the height. Okay, so that is my general setup for my equation. So now what I'm going to do is now they're going to give me an example. So when you have a 120 kilogram object lifted 1.8 meters, this is the work. Okay, so I'm going to plug all that information into this equation, use it to solve for k, and then from there, I'll be able to figure out the rest of it. Okay, because this k value changes depending on what problem you're looking at. Okay, so the work done when a 120 kilogram object, so my mass is 120, is lifted 1.8 meters, that's my height. The work done is this 2,116.8. Okay, and then I'm going to grab my handy dandy calculator and solve this equation out. Okay, so basically I need to divide this number by both of those. So I'm going to do 2,116.8, and you can either do divided by 120 and then another divided by 1.8, right? Or you could do divided by, and then in parentheses, 120 times 1.8. But either way, you're going to get 9.8. Okay. Okay, great. So now we know what our K value is. So once you have the K value, now you're going to be able to go back and answer the next question. So the next question asks you how much work is being done. So I'm looking for W when I'm lifting a 100 kilogram object 1.5 meters. So now I know that my K value is 9.8. So I can plug that in, right? And then the mass is 100 and the height is 1.5. Got the 1. There we go. Okay, and from there, this is a pretty easy, throw it in your calculator. The work done would be 1470 joules. And there we go. Okay, so not too bad. Okay, so that is kind of the general idea of what we're doing here. All right, so let's take a look at this next one. So this one, it says the heat loss through a single pane window glass varies jointly. Okay, again, we're looking for those keywords, varies jointly with the window's area and the difference between the inside and outside temperatures, which is D. So just going off of that, so my heat loss varies jointly, okay, with the window's area and the difference between the temperatures, which is D. Okay, then they're going to give me an example where we know the 3 variables that we can use to solve for K. So a single pane window with an area of 1, so I can plug that in for 1, and a temperature difference of 1 Kelvin experiences a heat loss of 5.7. So that is a really easy thing to solve. Obviously, K is going to work out to 5.7. Cool, and now we're going to go back here and we're going to plug that in. So what is the heat loss, right? So that's H. What is the heat loss? K is 5.7. The area is 2.5, right? And the temperature difference is 20. And then I'm just going to throw that in my calculator. So this should feel like, oh, hey, yeah, this isn't bad at all. Like, this is kind of a nice way to finish off the unit. Something nice and easy. And that's heat loss in watts. Okay. Quick side note. Sometimes the problem that you have is going to ask you to write the equation. So if you were writing an equation for this one, your final equation would be H equals 5.7 AD. That would be your equation if I were asking you for it. Okay. You got to make sure that you plug in your found K value. All right. Boyle's law. Remember talking about that in science class at some point? So Boyle's law states that for a constant temperature, the pressure of gas varies inversely. Okay, so varies inversely with its volume. So it's telling me that the pressure and then the varies inversely kind of tells me, oh, fraction. K in the top varies inversely with its volume. Okay, sample of hydrogen gas has a volume of 8.56. Right? I'm trying to figure out what K is. And a pressure of 1.5 atmospheres. So I can solve that pretty easily. So 1.5 times 8.56 is 12.84. Okay, and then they ask us find the volume, right? My K value I know. So find the volume. Oops, I'm totally messed that up. That's not where V goes. That's where V goes, right? There we go. So find the volume when the pressure changes to 1.2 atmospheres. So we have to solve this one. So a couple ways you can think about solving it. Stick a 1 under this one and cross multiply. You could solve it that way. Or how my brain works is I kind of mentally multiply both sides by V. So I'd have 1.2 V equals that number. And then to get the V by itself, I'd have to divide by 1.2, right? So ultimately, either way, we're going to take that 12.85 and divide it by 1.2. And we get a volume of 10.7 cubic liters. And there we go. All right, last one. So this one, companies found the monthly demand for its product varies inversely with the price of the product. Okay, so they found that the demand varies inversely with its price. Okay, when the price was $12.50, so just plugging this in, right? The monthly demand was 12,000. So I can use that pretty easily to solve for K. Lovely number that. So 1, 5, then it looks like 4 zeros. So 150,000. All right, we want to find the demand, right? Using my K value we just found if the price is reduced to $12. So I'm basically just multiplying that number by 12. So that is, let's see, a 1, 8, and then it looks like 1, 2, 3, 4, 5 zeros. Lovely. So 1,800,000. Okay. And that's all there is to it. We didn't do any that just were direct variation. Okay. But if it just was direct variation, it would be the same thing as a joint variation. You would just have one fewer letter. Okay. So if this had said it would vary directly, you would just have W equals KM or W equals KH. Okay. So it's the same thing if it's just varying directly. Okay. So that's your variation. And again, just the thing to watch out for is make sure that you can identify, given an equation, whether it's inverse or direct variation, okay, or joint variation. And you should be able to do that in either one of these formats. So if they gave you something in a format like this, you should be able to rewrite it to this and say, oh yeah, that's direct variation. Or if they gave you something like this, right, you should be able to, oh yeah, okay. Okay, so you just got to watch out for the fact that like these look really similar, okay, but the difference is what's being divided, right? Does it equal K or does it equal Y? Okay, so just watch out for that one.